Everybody, welcome back. We're going to continue chapter 8 now with section 8.7 on dilutions. So a common laboratory practice is to prepare a concentrated stock solution of solute and solvent and then dilute it to the concentration needed for experiments by adding more solvent. And so the dilution is the process of adding more solvent to a solution to lower the concentration of the solute. So you may already be familiar with doing dilutions at home or at work. Like you take concentrated juice solution, for example, and you add more solvent, water to it to dilute it to the concentration of which you want to consume it at. Or you might take a concentrated, energy drink type solution and dilute it into a larger volume of water, your solvent, to get it to the concentration you want. Or diluting bleach. This is something that's commonly done for, cleaning and disinfecting. You want to make a 10% bleach solution, you take your concentrated solution, you look at the label to figure out its concentration, and then you dilute it to get the final concentration that you want for cleaning or disinfecting. So dilutions are incredibly handy, of course, in the chemistry lab, but also just at home. It's a good thing to know how to do. So to calculate dilutions, you need to know some concentrations and some volumes. So S stands for your stock solution, which is the more concentrated solution, and D stands for the diluted solution, which is the more dilute solution. So stock solution is your concentrated, and the dilute solution is your less concentrated. So if you know your concentration of your stock solution and the volume of your stock solution, concentration times volume of your stock solution is going to equal the concentration times the volume of your dilute solution. It's really important when using this equation to calculate, like, let's say you want to make 0.5 molar solution and you want to make 500 milliliters of that dilute solution, and you're starting from a 2 molar solution. You want to know how much of the 2 molar solution you need to dilute. You have to make sure that your units on both sides are the same, so that when you rearrange this equation to solve for your unknown, all of your units cancel out except for the one you want to solve for. So your concentration units need to be in the same unit. In this example, they're both in molarity, and your volume units need to be in the same units. So if I have milliliters on one side, when I solve for volume on this other side, I'm going to be solving for volume units in milliliters. So just make sure when you set these problems up that your units, you convert them before you start plugging values in so that your units end up canceling out. So let's just solve this one out quick. So this problem would read something like, a scientist has a 2 molar solution of sodium chloride in the lab, and they want to dilute that to make 500 milliliters of a half molar solution. How much of the 2 molar solution do they need to add to make a final solution that's 500 milliliters and half molar in concentration? So to figure out how much of the concentrate you need to prepare this dilution, you would rearrange this equation to solve for Vs, the volume of your stock solution, which once you rearrange, you divide both sides by your Cs. So you get volume of your stock solution equals concentration of your dilute solution times volume of your dilute solution divided by concentration of your stock solution. And at this point, you want to plug in your numbers. So our concentration of our dilute solution is half molar. Our volume of our dilute solution is 500 milliliters. Our concentration of our stock solution is 2 molar. And if you check your units, molar and molar cancels out. So we're going to be solving for how many milliliters of the stock solution we need to use to prepare our diluted solution. So 0.5 times 500 divided by 2, we need to use 125 milliliters. So that's a very kind of simple concentration problem. We'll do some more examples as we go through here. And again, make sure your concentration units match and your volume units match. So when you rearrange this equation to solve for whichever one of these is unknown, your units end up canceling out. So let's do an example here. A person wants to dilute a concentrated Kool-Aid drink, which contains 35.5 grams of sucrose, sugar, for 50 milliliters of concentrated Kool-Aid solution. How much of the concentrated Kool-Aid does the person need to prepare 150 milliliters of a dilute Kool-Aid solution that contains 9.5 grams of sugar? So if you can imagine, person made a pitcher of Kool-Aid that's incredibly concentrated, right? Super, super sugary. And they want to take a small volume of that and dilute it with some water to make a less concentrated solution. So that in the resulting solution, they have less sugar. They started out with 35.5 grams for every 50 milliliters of solution, and they want to end up with 9.5 grams per 150 milliliters of solution. So this is something you might do in the summer. Let's say you want to make a really concentrated iced tea or really concentrated juice or Kool-Aid solution, store it in your fridge, and then every time you want a glass, you don't have to make the whole solution. You can just dilute the concentrate down to the final concentration that you want. Okay, so we're givens. We have 35.5 grams of sucrose for every 50 milliliters of solution. That's our concentrated solution. And we have 9.5 grams of sucrose for every 150 milliliters of solution, and that's our dilute. So we're going to use concentration of our stock times the volume of our stock solution, and the stock is always the one that's more concentrated, is going to be equal to the concentrated of our dilute solution times the volume of our dilute solution. So grams of sucrose per milliliters of solution, that's a concentration. We could calculate this out to make it a mass volume percent concentration. Grams of sucrose per a given volume of total solution. So I'm going to use this as my CS. 35.5 grams of sucrose for every 50 milliliters of solution. We're trying to find how much of this concentrated solution we're going to need to mix in to make our dilute solution. So that's our question mark. The concentration of my dilute solution is that we want it to end up with 9.5 grams of sucrose for every 150 milliliters of solution. So 9.5 grams of sucrose for every 150 milliliters of solution. The volume of our dilute solution is that we're trying to make 150 milliliters total. 150 is part of the concentration factor. We want there to be 9.5 grams of sugar, sucrose for every 150 milliliters of solution, which means we're making 150 milliliters total. That's like what we want our final cup size to be. So now we have every value, concentration of our stock solution, concentration of our dilute solution, and how much dilute solution we want to make. So we have everything except for our unknown. So we can rearrange this equation to solve for the volume of stock solution we're going to have to use. So volume of our stock solution, if we divide both sides by concentration of the stock solution, it'll cancel out on the left, and we end up with our concentration of dilute solution times the volume of dilute solution divided by concentration of stock solution. So if we now plug that in, we get 9.5 grams over 150 milliliters times 150 milliliters divided by 35.5 grams for every 50 milliliters. And if we check our units, milliliters and milliliters cancels out here, grams and grams cancels out, and we're going to just be left with milliliters, which we're trying to find a volume. So that's good that that checks out that we're trying to find a volume and we're left with units and milliliters. So if I plug this in, 9.5 divided by 150 times 150 to get the top part here, and I get 9.5 divided by, on the bottom, 35.5 divided by 50, 0.71. I get 13.38 for the volume of stock solution. 13.3802. And if we check our sig figs, we've got 2 sig figs and 9.5 grams. And we've got 3 sig figs and everything else. So this would be rounded to 2 sig figs. 13 milliliters of stock. So that means to make the solution, what you would need to do is you need to take your 13.38 milliliters of your stock solution, put it into a container, and then fill the container up till the total volume is 150 milliliters. And now the concentration of the Kool-Aid is that you have 9.5 grams of sucrose in that 150 milliliters of solution that you just prepared. Let's do another one. So in this one, a nurse wants to prepare 500 milliliters of a 6.5 milligrams per milliliter solution of morphine. So this is what they want to make. So this is their dilute solution. They want 500 milliliters of this 6.5 milligrams per milliliter diluted solution. They're preparing it from a 1 gram per deciliter stock solution of morphine. So how much stock solution and water will the nurse need to mix to make the final solution? So I'm going to do this one on a whiteboard so we have a little bit more room. And I give a hint here, you're going to want to start by doing some conversions, because when we do these dilution calculations, your units need to match on both sides of the equation. So we're given one concentration in milligrams per milliliter and the other concentration in grams per deciliter. So we're going to have to change one of these so that the units match on both of them. So let's go over to a whiteboard. Okay, so given our concentration of our dilute solution, we want it to be 6.5 milligrams per milliliter. That's what they want to make. And they want to make, our volume of that diluted solution is they want to make 500 milliliters of it. And then our concentration of our stock solution is 1 gram per deciliter. And we want to figure out how much of this concentrated stock solution do they need to use to make 500 milliliters of a 6.5 milligrams per milliliter solution. So we're going to use our CS times VS equals concentration of our dilute solution times volume of dilute solution. But our units need to match. And right now, our concentration of dilute solution is in milligrams per milliliter, and our concentration of stock solution is in grams per deciliter. So the first thing I'm going to do is I'm going to convert grams per deciliter to milligrams per milliliter so that my concentration units match on both sides of this equation. 1 gram per deciliter to milligrams per milliliter. So I have grams per deciliter. My first thing I'm going to do is convert grams to milligrams. So there's 1,000 milligrams and 1 gram is the conversion factor I'll use. And that will give me milligrams per deciliter. And then I want to convert deciliters to milliliters. so that I end up with milligrams per milliliters. So 1 deciliter is equal to 100 milliliters, and that was from our slide on clinical concentration units. 1 deciliter equals 100 milliliters equals 10 to the negative 1 liters. So I can go straight here from deciliters. 1 deciliter equals 100 milliliters to convert deciliters to milliliters. So let's plug this in. We have 1 gram per deciliter times 1,000 milligrams per gram times, for every 1 deciliter, there's 100 milliliters. Let's flip that here too. If we check our units, grams and grams cancels out, and deciliters cancel out, and we're just left with milligrams per milliliter. So we end up with equals 10 milligrams per milliliter. So this is our concentrated of our stock morphine solution in units that now match the concentration of our dilute solution. So again, it's really important that your concentration units match on both sides of the equation, as well as your volume units. Because our volume units are in milliliters, when we solve for the volume of stock solution, we're going to be solving for milliliters of stock solution. So now we're ready to plug this in. We want to solve for Vs. So we're going to rearrange the equation to get Vs by itself, which means we're going to divide both sides by concentration of stock solution to get CD times VD divided by CS equals Vs. And now we're ready to plug in our units, our actual numbers, because we already fixed our units issue. So our concentration in a dilute solution is 6.5 mg per mil. And our volume of that is we want to make 500 milliliters. And our concentration of our stock solution, we converted from grams per deciliter to milligrams per milliliter, so our units cancel out. It's 10 milligrams per milliliter. We check our units, milligrams and milligrams cancel out, milliliters and milliliters cancel out, and we just have milliliters left. And I get 325 milliliters. Now, if we check our sig figs, we only had 1 sig fig here. Our metric system conversions were infinite, so we end up with 1 here. We have 2 sig figs here, 1 sig fig and 500, 1 sig fig here. So we should round this to 1 sig fig, 300 milliliters. So how you would actually prepare this if you were making it, we know we need 300 milliliters of our stock solution. So what you would do is you would take your stock solution and you would measure out 300 milliliters of that. And then you would add it to a 500 milliliter volumetric flask. So you'd have your volumetric flask down here. You put your 300 milliliters of your stock solution in. And then you'd fill it with water up to the line, which represents 500 milliliters. So that your 300 milliliter stock solution was diluted to exactly 500 milliliters of your diluted solution. And we do it this way because, again, volumes aren't necessarily additive. So you can't say that you need 300 milliliters of stock plus exactly 200 milliliters of water to make 500 milliliters total, because the densities of the two solutions might be different. They pack together differently. And so the best practice for making these is to put your stock solution in a vessel and then fill the vessel up to your final volume that you want to achieve. In this case, it was 500 milliliters of the diluted solution. And again, that's to account for the fact that volumes don't add up together. So 300 milliliters of stock, plus if you just added 200 milliliters of water, might not equal exactly 500 milliliters of the final diluted solution. Oftentimes, depending on what you're mixing, it gets pretty close. So you can, take a little shortcut and just add 200 milliliters of water. But the most precise way to do it is as described here, where you take your stock solution, you put it in the bottom of a flask, and then you fill the flask up exactly to the 500 milliliter mark with whatever your solvent is, water in this case. Okay, so quick summary of what we've learned about solutions and concentration so far. Solution is a homogeneous mixture of two or more substances in which each substance retains its chemical identity. Solutions are always made up of at least two parts: the solvent, which is the component of a solution present in the greatest quantity, and then one or more solutes. So if you're trying to figure out which is which, you look at how much of each substance you have, and whichever one you have the most of, that's your solvent, and all the other ones are your solutes. We went over 4 different ways to calculate the concentration of a solution. 3 of them were percent concentrations. For example, percent by mass, percent by volume, and mass volume percent. And then the 4th was molarity, which is moles of solute per liters of solution. So the rest of chapter 8, we're going to talk about different types of solutions and dispersions and suspensions. And then we're going to talk about colligative properties, and we'll wrap it up with talking about osmosis, osmotic pressure, and hypertonic, hypotonic, and isotonic solutions. Thanks for listening. I will see you then.